Hello. Thank you for coming today. I know Sally already thanked you. I'm Jenn Allen, and I'm going to be talking today about how you can use open source CI to accelerate product innovation. So what we're going to cover today is really briefly what is CI and some examples of that. I'm sure most of you or a bunch of you are familiar, but I wanted to make sure that we tailored this talk to a wide variety of audiences, including those who maybe might not know CI or why it's important, or might not think it's important. Why would you want to use CI? And what are some of the challenges, maybe some of these that you've run into as well? And how can CI help product teams innovate faster? We'll also look at an example product workflow. And as a product manager and as a stakeholder in general, how could this help you? So briefly, just about me, I was previously a PM at Dagger. I helped launch Dagger Cloud and the Daggerverse. Daggerverse is a community source for the community to publish modules and extensions for Dagger functions. We'll get into that in a bit. I'm currently studying AI and learning how to build neural networks and working with NLP. Okay, so let's get into what is CI. So conceptually, CI is a way to build, test, and release software predictably and consistently. But literally, it's a software workflow and set of tools that helps automate tasks like building and testing your software. Things that you can do manually, and often that teams that are smaller will do manually. And at some point, it becomes complex, and you need more consistency, so you look at tools. These things can be services, like SaaS services like GitHub Actions, and they can also be things that are self-hosted. Many people use Jenkins, for instance. It's still very prevalent. I worked at CloudBees and know Jenkins very, very well. So here's a very high-level overview of an example CI workflow. This is what you will see if you go to Wikipedia and search for CI workflow. This is a really simple example of showing how integration from start to finish with your development workflow from your Git version control to your version control system workflows, whether you're hosting those yourself or using a SaaS service. So the basic concept is that you need to check in your code. That code then needs to be integrated. That's the standard integration that you have through Git version control. But as part of that, you also want to have automation that verifies that those things are working properly. So for instance, you'll have verification tests through unit tests, integration tests. You'll need to build the software to begin with, install the proper packages, and then you'll need to also potentially do things like create security software bill of materials for the security team and other sorts of verifications. And then finally, you may also continue to do continuous deployment or continuous delivery, which I won't be covering in this talk, but it is the next phase that some teams do, and you can use these tools for that. But that is not always necessarily required as part of continuous integration. Okay, so there are so many CIs. This is a list of at least 10. There are many, many more. So some that you may be familiar with: GitHub Actions, GitLab CI/CD, Tekton pipelines, Argo CD, and also some teams choose to build their own. I do not recommend this. I have been on a team that has built their own. You can do it, but you will essentially be creating an entire new software product team. So something to consider. You will realistically have to have a team, someone who's already in operations, working to manage this system. Sometimes that's the software reliability engineering team. Sometimes that's a DevOps team. Platform engineering, it's really kind of changing about what this ends up being, the name of this, but you need to have that team work very closely with product and engineering, because I see this team and CI in general as being part of core product, not just a separate team. It needs to be integrated. So why should you consider using CI? So first, you want to reduce bugs and improve quality. You can do these tests manually, but you probably shouldn't. I'd say the minute you start working with one other person, I would at least create a test to integrate, or I would at least integrate linting rules, because you're probably already going to be arguing about that to begin with, so might as well create an automation to test that. You're also going to want to automate unit and functional tests, integration tests. But the problem is here, once you're doing any of this testing, you have to write the tests. So as a product manager and someone with a lot of product experience and now doing more development, I implore you all to write tests and require them as part of feature complete when you are working on any enhancement or bug as part of your product. Another reason is compliance. So more and more, there are more tools out there that enable you to integrate them into your software workflow, to see what's actually in your bill of materials, to auto-generate that, to do security scans, enable you to then override those rules. This is very flexible and very easy now to use. I really recommend that you check that out. The actually most difficult part of this is defining those compliance rules and getting alignment on them. If you have gone through any sort of SOC 2, Type 2, or Type 1 review or audit, many of those tools will, like I think Vanta, for instance, will integrate with GitHub and other tools, and you can use that as a way to continue if you have additional like spot audits to see if you are still within your like audit compliance. Another way is to accelerate product innovation, which is what we're talking about today. So what you can do too is if you have a web app, you can create preview environments as part of a pull request so that your stakeholders and product managers can go and see a new UI feature and test it out and verify it before it goes out to production to your customers. It does require the infra and services teams to work together to actually enable that. You will have to also allocate budget in order to support the preview environments, and you'll need to make rules about what actually gets a preview environment. And part of the demo that we'll go through here today actually provides an example of a way that you could get a similar experience to a preview environment with actually not creating one. And then the last one is to make some impressive dashboards. I am being tongue-in-cheek here because we do need to do monitoring, and we can sometimes go overboard in our dashboarding. But sometimes I'd say start simple. Look at what's already built into your CI tools. See what plugins you have. See if there's a necessary for you to actually pull metrics or create custom metrics. But it is going to be important for you to see what's going on in your CI because it will break, no matter what tools you're using. And then developers will be blocked from being able to actually push their code to production because CI is broken, and you need to know that things are actually going out quality because otherwise you could be releasing bad code to your customers. Okay, so let's actually look at CI in practice. So one of the challenges that we have with CI is that we've lots of choices, which is great, but we also then have lots of different configurations. And if any of you work at a company that has acquired multiple companies or that has teams that want to work with different CIs and you happen to be, say, a platform engineer, you know that you then have to manage multiple configurations. You probably have a standard policy across the company that says all software must do X or go through these workflows. So often then you create a tool or wrapper around that to try to ensure that you have some sort of conformance. So there's a lot of challenge that is not obvious when you start adopting CI, especially as you start to grow. When CI fails, it can be very difficult to debug. You are actually now, like in this production workflow, it can be very challenging. You could have an on-call incident, and now you have to figure out what's going on, and you don't want to be in the critical path. Ideally, you really want to know what's going on. It can also be time-consuming to create CI pipelines. You have to learn the syntax and the configuration options. You have to go and do the appropriate changes to any of the rules that you have for your visual source code system too. And also your CI systems can't usually easily be tested, so you'll need to do something like clone the repo, create your workflows, test them out, and then like push those workflows to production. These are all things that you easily can do. These are just some of the challenges that you run into. And then the last one is, that's why the Keanu face is there, is that it starts simple. We can grab a GitHub Actions workflow or a GitLab CI/CD workflow and deploy it and say, here's my linting rule, it's very easy. And then you want to add more and you want to add more. And something breaks, you're not necessarily sure why. And now you have potentially, I've seen thousands of lines of YAML. I'm not subjecting you to an example that I have, but it can be very challenging. So there's a lot of power and there's a lot of potential issues that you can run into. So one tool that can help is Dagger. Dagger is an open source tool. It was started by the founders of Docker, including Solomon Hykes. And so rather than writing all of your workflows directly within the CI in that configuration language, you're writing them in code. So the SDKs that are officially supported are Go, TypeScript, and Python. And these workflows then as code can be directly written in your IDE and debugged. And they're modular, testable, and extensible. So within the Daggerverse, there's a whole set of modules and functions that you can reuse. And within the last 6 months, Dagger released a feature that now allows you to reuse functions across languages. So if you prefer to write your code in Python, you can now use a module, say a linting module that's been written in Go for your Node app. So it allows a lot of extensibility without you having to rewrite things, a lot of the general dry concept. And one cool thing with Dagger is you can also run locally and in CI. It's the same code. So your source code your Dagger source code sits along with your application source code. And when you check out the code, it comes along with it and you can run it locally. We'll have an example in just a minute here too. So some prerequisites. Dagger uses OCI compliant containers. If I'm running locally, say as a PM, I'd install Docker Desktop. You'll need the Dagger CLI. If you're running locally, you'd run the Dagger CLI via the terminal. If you're in CI, you would call out to it for the function in your CI workflow. And then you just need to choose your preferred coding language. You can create your own SDK if you'd like as well. So let's look at an example workflow for a product manager. So our goal, we want to do early validation. As a product manager, I want to be able to check out a developer's work in progress from source control, and I want to easily run it locally. I don't want to have to wait for it to be done or to be told that it's in production. I want to work collaboratively with my designer, my engineer, and anybody else who's a key stakeholder in the team so that we can quickly get the code out there, be flexible, but also not be waiting on assuming that done is done. We also want to have a consistent experience. So as a developer, one of the nice things about being able to run locally is that if it's the same code that runs in CI, if it passes on my machine, it's going to pass in CI. So one of the examples we have here is an enhancement to a docs website, something super simple. We want to be able to add the option for customers to provide feedback on our docs. This might be a little challenging to read, but it is a feature ticket that I wrote out, an example of what a PM might put in with to say the justification of, we've heard from various sources that our customers tell us our docs aren't easy to read, that they're not getting the appropriate information that they need to be able to configure their dashboards correctly for this product. The hypothesis is that we provide this, our documentation will go up, our customer satisfaction will go up, and then it has a set of requirements. But part of the requirements is also that we work iteratively as a triad with a design and engineer and PM. There's a couple low fidelity mockups, and the reason why you don't see high fidelity mockups there is that the team is working iteratively together and are using a UI design library and standard UI specification so that you can just quickly use those components to put them in the UI and not have to rely on a really long turnaround time frame with a designer. So in this example, the developer then sees the ticket, we collaborate together, they create the branch, and they push that to GitHub in this instance. And then they create a draft PR. And this is the place where we start to collaborate. We talk within the linear ticket, that's the ticket issue or the project management tool I was using in the last example. We talk in GitHub and asynchronously. And then we have pairing sessions and we get the feature done pretty quickly. In this particular example, it's just a front end. We've already have the back end service and the database where all this is going to be managed. We've done all the compliance and GDPR and privacy reviews. So we just need to implement the front end. So this is an experience that as a PM, I could go then into GitHub Desktop, find the branch the developer added, check it out. I then go into my terminal. I have Dagger CLI already installed. Docker Desktop is running. And then I say Dagger call, and I tell it that I want to build, and my source code is at the root. and I want to run a service. And so one of the things that Dagger can do is spin up containers, not just to build, but to actually run active services for you. That includes things like ephemeral tests that you'd want to do, and also long-running services like a web server. And that's what we're doing here. You see that now, once it completes the process, it emits a URL on my local host that I, as a PM, can then click, and it will open the tab to my browser. So it's very similar to a standard local build process. But one of the things here is that all of these steps here, creating the Linux container, installing the necessary packages and components, building the web apps, starting the web server and services, running the tests, I could run npm start or npm start dev, but as a PM or another stakeholder, I'd have to have a lot of different tools installed. If the dev packages, the package JSON, or any of the other components had moved over time, now I potentially am in a situation where I'm having to figure out and debug why my system is out of sync from the developers. I've done that so many times. It's very frustrating. And I'll tell you that Dagger definitely changed the game for me as far as being able to quickly see what's going on without having to install a lot of components and debug what's just to be able to run the code. So here's the example. I said earlier that Dagger sits along with your source code. So this is a repository that I created as an example. And you can see that there's a Dagger folder and the Dagger JSON. So the workflow is defined in Dagger source. So that's where, say, your Python init, like your main function would be, main method would be defined, or your Go code main method would be defined. And then your base definition is the Dagger JSON. That's where the name of your function, like what you actually call, would be there. And then all of the preceding workflow was defined in code by an engineering team. So this typically would be defined closely with a DevOps, a platform engineering team. And you define each of these as functions. You have a build function, and these can be chained. So the test function could be chained off of the build function and call that. And then you can specify, I want to use a Linux container that's running Alpine in this specific version. You can pin the versions that you want to use within each of those functions so that you're not having to do the version hell situation that you might be running into with trying to run it through and figure out what version's being specified in a line of YAML. And then these functions you can directly call through the CLI. So I can say Dagger call build, Dagger call test, and each of these can be specifically run separately. And all of this is, as I said earlier, runs the same locally as it does, let's say, in this example, in GitHub Actions. This is showing an example of how to call a Dagger pipeline or workflow within GitHub Actions. So we have a call out to the function within one line, and we're also specifying that we need to use the Dagger CLI. You can also use this with Jenkins and a declarative pipeline. And there is as you start to adopt Dagger, it's not an all or nothing. You can start to do pieces of your workflows over time too. So that can be intimidating once you start talking about potentially migrating or trying out a new tool that say, oh, I've got to scrap everything. You do not. There's guidance within the Dagger docs and on their community site. So the end result is that you get faster feedback cycles. I can easily then just check out the latest version of the PR or of the branch and rerun the workflow so you see what's there. I get a consistent experience locally and in CI. No more worrying if my changes will break in CI. I know that they run locally, they're going to run there. And I have more innovation and less time debugging CI. So that is the end. We have a few resources for you. There's the Dagger website. The Dagger team is on the Discord server. They're very active there. So if you have any questions, I'd join there. The YouTube channel, that's where the team has bi-weekly their community calls. They are now live streamed there. And those community modules, which are reusable, are up on Daggerverse. And feel free to reach out to me if you have any questions. I'll be around the conference. You can connect with me on LinkedIn, or you can follow me on GitHub. But thank you.